So, um, this is a VariCAD interface. Um, this is, as you know already, a CAD, a 2D, and a 3D CAD. VariCAD did not follow the current trend to make the upper part of the software with a ribbon look-like appearance. They are with this type of appearance, even that they renew a little the icons and the global appearance of stuff in these latest versions, but they maintain the general look of the software for years now, and which I do think, in my personal opinion, it's a good stuff. Okay, so this is the appearance, as I said. Um, this is a 3D side, and we have also a 2D side, um, basically changing. Basically changes with a click on an option. So now we are on the 2D side. The icons change accordingly to the 2D side because the type of entities it is different. This is important also because it's one of the advantages of the program, that we can have 3D entities and also 2D entities, and only one file. Okay, VariCAD does not create several different files for each stuff, so you have everything in only one file. I will, to start and showing a little how to handle this, I will open one of the samples that came with the installation. Doesn't matter what it is, just to show you a little. So this is the type of thing, a simple part, okay? Handling with a part. If you see uh, in this lower right corner, you see the mouse, and whatever I do or click, you can see what is clicked, okay? So to make this rotation, I keep the right mouse button pressed and just drag, and I do this kind of behavior. Um, the middle mouse, or in this particular case, the wheel, will make what we call the pan. And if I scroll the wheel, I can do this zoom in, zoom out. So I think it's easy. The left mouse button will make the zooms. I'm not choosing anything, so it's not doing anything, but it's to show you that I can make selections or other kind of stuff. And as I said, in 3D we have this type of entities. This is a solid. In 2D side, we had already a projection, so we have lines, circles, arcs, that kind of entities of 2D. And basically I can handle, in terms of the pans, the zoom in, zoom outs, on the same way, okay? So the pan with the wheel, zoom in, zoom out, and you cannot rotate on this side with the right mouse button, so you have access to other functions. But this is to give you a basic idea. Before we make a little example and to go through some functions, to give you 2 or 3 more highlights of what we can do with the software. Any kind of part, we have different approaches to create the part, and And we can do this because having a unified file format which has everything inside, so you can go and create a solid. Okay, I will do very standard stuff. We can do or create anything starting on the 3D side, or we can go in the 2D side, create a profile, whatever we want, and then with the proper data, for example, create an extrusion and create a solid from the 2D side. Okay, two different approaches, and we will run through them on the example. Also, things like, okay, I'm deleting these two guys. When we have the work finished, being the parts or an assembly, whatever we have, we can go on the opposite direction, which usually it is from a 3D part model assembly, create views. There are a couple of options. I will use them all. Okay, I will not go through these minor options now. And with this kind of easy and I think very quickly we can create the views and the corresponding 2D entities. Now, being a 2D drawing, we can create what is usually created on the 2D side. Okay, the graphical arrangement, dimensions, support lines, title blocks, whatever it is on the 2D side. Okay, so these are two different approaches that we can have. Besides this kind of, I would say, standard work, we have other support functions. For example, libraries that came along with the installation of VariCAD. This is standard. VariCAD does not have any additional modules. So we have library of parts, standard parts, which can be DIN or ANSI or the Japanese regulations or whatever it is. But these kind of parts, okay, you choose whatever you want. Options about what to be seen, insert, and that's it. This is for 2D. We have library of parts, also bearings, but we have also some symbols which are interesting and useful. This kind of thing if we are making diagrams or whatever, because the 2D work does not end in making projections of parts. On 3D side, we have the same, not the symbols, but in terms of the library of parts, we have the same kind of stuff to make something similar. Okay, and we have this kind of stuff also. Okay, so these are useful things. These libraries are not open. They will be open in terms of being possible to add new things in one of the future versions, and not too far away from now, because it is something that is discussed already. But for the moment, these libraries are not open. Okay, and pretty much the major stuff about what I can show you to give you a basic overlook of the program. So the idea now was to create a very simple part to see a couple of options around it, okay? So I will close this drawing. I will start a new one. Nothing open. And this part is a very simple part. Is a plate, a L-shaped part with a hole. We can do some things around it. But I would like to start with the easiest, and I would say the simplest the simplest way to create a part, which it is to go through basic solids. Okay. So we have a couple of options. These toolbars and the group of toolbars that we have here, they are what we call, they are tiered off toolbars because we can grab them and bring them in for any other place on the drawing area. And we can assess the functions also going through the menus. There is a lot of stuff. As you may imagine, the toolbars don't have all the icons, so they have a configuration which is standard from the installation, but we can change it. So very simple part going through a box, and I have a box. I will use millimeters. My apologies, but inches are not very okay. But these are dimensions, so it should not be very. Or the concept, it is the same. Okay. So dimensions, I can choose from a bunch of colors, so not really important. And confirm, and I'm creating something. I made a mistake. Sorry, I go back again. One of the dimensions was wrong. So 20. Sorry. So I have this to be inserted. Every time I do the insertion of a component, I have this relocation bar that we will see a little up front because there are important stuff around here. For the moment, I simply want to say OK. And I have a part, OK, solid. I will add a new one, and I basically have the same dimensions. So the program chooses the last location to insert the new part, but I don't want the same location because I want to do a L-shaped part. So now I can use either this toolbar with the locations, or I can use these arrows that we have here for each of the axes. So I can make a lot of transformations with this. So I can use, for example, this part with the arrow. I'm trying to grab it, and for some reason I'm having problems choosing this arrow. Let's try another one, because this graphically my computer is not the best, but well, okay. Sorry, because I'm okay. For some reason I'm having some graphical issues here. So I can choose a translation distance with this part of the axis, this outer part, and I insert a distance here, for example, and I get a transformation. Okay. If I choose the inner part, Yeah, this is today. I think it will be an issue to choose this. Okay, but let us be patient and try to. Okay, okay. I will be fighting with this part. The inner part of the axis will allow to make this dynamic transformation. Okay, there is a step defined in this particular case that will move 1 millimeter each step. Okay, I can control it also easy, but this is the difference. Dynamic the inner side and with a fixed distance for the outer side. In terms of these symbols here, it's the same but for rotation. Okay, and on this side I can give an angle. I have already defined values, for example. Okay, or on the small it, it will be I'm fighting with this guy today. I'm fighting with this guy, but let's try to overcome this. Because I'm not working in my regular computer because of the connection to the internet, and because this okay, I
don't have a great computer either, so
but okay, okay, anyway, this is trying to show you the dynamic, but I'm not being able to choose it for some reason. Okay, it doesn't matter. So this is one way to do it, or we can do it also the same functions and also and some additional ones through this toolbar. So for example, in terms of rotation, for the arrows, if I go to the x-axis, I can do by angle rotation or a dynamic, which it was basically what I was trying to do. For example, the midpoint. This is graphic. Okay, let's try to survive these graphical problems. I can rotate also with 1 degree step each time, okay? And this way I can do my transformations. Or what I usually do, we can also make transformations going through some important points like the endpoints, midpoints, centers, and so on. So, for example, for this particular case, if I turn my part now, I will not insert it on the position I want. So first, I need to redefine my reference point, and I need to use this option here, which is quite important, and define a new insertion point. And I can say midpoint, okay? And now I will use this toolbar today. Let's do a rotation angle, and it's important to see the direction for the positive or negative value. In this particular case, I want to rotate it on the direction of the arrow, so it will be 90 positive. Okay, and I have it already on the position I want. It's not still on the position I need because I would like to have the thickness inside of this plate. So I can, this time, I can move it behind, this time negative movement, because I have a thickness of 20, minus 20, and now it's on the position I want. But these two parts are, I will make an insertion, these two parts are two different parts, not one single part, okay? Because they were created of two solids, so I need to join them and create one single part. So I have some Boolean operations, add solid, cut solid, some variations, keep the cutting solids and whatever, but basically we have three Boolean operations: the addition, the subtraction, and the intersection. In this particular case, I want to join both, so simply click one. If I can do the selection, and now I have, you see, when I go through it, I have one single part, okay? One solid. As I said, when we start, we can do this directly from 3D, or could come from the 2D side, create a profile, and then a solid also. Let's try to create the same now on this side. Several options, so I will use the basic one, the line. It's not very important where I start, because I suppose you have a little experience of 2D, if I do remember.
Yes.
Okay. So you know that in 2D we work with coordinates, which are of several types. They can be absolute coordinates, and that is considering the origin of the program, or world coordinates, or we can work, which is easier, with relative coordinates, one point relative to another. In this example, I want to create a profile similar to that L-shaped part we had on the 3D. So I will click one point, it doesn't matter where, okay? And now I need to start defining my profile. So I will use dx dy, that means relative, okay? And this is always like this, from last point. X direction horizontal, Y direction vertical. So X 80, because it's positive on the direction of the arrow, on the opposite direction negative values, and this is for any of the axes. So in X 80, in Y 0, and that's it. Now I want to go up 20, so 0 here, 20 here. Okay, for you this concept, or?
Yes.
Okay. So now backwards, so minus 60, 0. Going up 60, minus 20, 0, and we could give the last one, or back to cursor and going here, and finish it. Okay.
Now, when you finish it, are you pressing a certain key, or
Usually, if you do the click with the right mouse button, it's enter, or if we have a function, okay, if we go into this toolbar that is called location pop-ups and it's always up, if you go okay, it finished. Okay. If you let us try to, I will do the right mouse button click and the same behavior. Okay. Select and delete, or the delete key in your keyboard. It's the same. Okay. So we have a close profile. Usually we go to this icon here, which allow us to create a solid with this type of functions: extrude, rotations, lofting. Basic one, extrude. So the height of the solid, if I'm not mistaken, in this particular case, it's not the height because you are already defining the profile, but it's the depth of the solid, but it's the same. So 90. We want to define these two things because allow us to have a proper definition of the orientation on the 3D side. Choose profiles. Okay, selection. Again, either here or right mouse button. And it is important in VariCAD to be aware of this line below, because it will talk with us. It will show us the messages or whatever he's asking us. So it's important to be aware on this part of the program. So now he's asking us for insertion point. So I will use this guy here, and you see the message here. Define the axis, the x-axis direction. I will choose this one. And okay, I will put this a little away so that we can see the difference. And do the OK. I will change the color of this guy so that we can know which one it is. So edit, color of solids. So we know now that the green solid is the one we've done on the 2D side. Okay, but they are equal solids. Let's add a little more features to our solids. For example, to create some fillets. Usually this kind of item should be added as the last thing to do on a part, because fillet chamfers this final arrangement sometimes give problems in any software, and it is important to leave them to as a last operation, because if we keep doing things on the parts already with fillets and so on, it's not very uncommon to see the programs giving errors and so on. Okay. But I'm saying the fillets now, but I will choose to add a hole first. Sorry. We have a couple of operations which can add some shapes also into the part, being a hole, being a cut or a groove. Okay. For example, a hole. Let's choose a solid and let's give some parameters. which in this case it can be, for example, a diameter of, let's say 15 or a little more, 20. Depth, whatever it is, higher than this plate here, so we have 20 millimeters thickness, so if we say 30 it is okay. And what they call the outer tool excess, which is something that will stay, will not be visible, but it's a value that the program needs to guarantee that it's a through hole, okay? And it will solve the math of eventually we create a hole, and this hole is placed or created face with the solid, and sometimes it's also a reason of having problems. So they fix this saying a little excess. I usually say 5. It's not important. We have a couple of options that if we want we can choose. Okay, I'll not do something about it in this particular case. So you see this distance from here to the top of the hole, it's the 5 I gave on the dialog box. Okay, so I want to position this right on the middle, and I have a function that says halfway between points. So halfway, and then I get this toolbar which I can choose, and this way I guarantee that it's on the middle. And when I say OK, it creates the hole and keep asking me for new places. I will use the hole and I will do the same on this side. So halfway, if I go here, I'm not sure if I'm choosing the correct place because I'm with this graphical stuff, but I suppose so. Okay, probably not. Anyway, let us repeat the command here. So halfway, and okay. Very good. Now that I have the hole created, I will add some fillets. For example, I have a couple of options also. Continuous edge, single edge, a patch outline. It's for this particular example, it's basically the same. So I can do this thing here. Let us say a 5 mil radius. I can do also in the back, again 5. I can do here, and I can leave like this, okay, for example. I will do a similar thing on this one. And do them all in one time. Okay, very simple stuff. Now, this is a very simple part. And one of the things I'd like to show you, it is how to edit a solid. And you probably noticed something, because even not having experience with 3D CAD, you probably have seen already some programs working, or at least read or heard someone that usually 3D CAD softwares have a tree where the program shows all the operations, and then you go to that tree, choose an operation, and you are able to change things after they are done. This is one of the advantages of having solids. Okay, I'm not sure if it is the case or not, but I suppose so. In this particular case, VariCAD does not have that tree, but I think it's a good thing not having it. It's a little more flexible not having that function. And we have two important functions here, both of them to edit. This one does addition in terms of transformation. This one makes additions in terms of changes to the shape. Okay. So first, let's try to transform something. We don't have much thing to transform in this part, so I will use the whole. Okay. We have a concept here, which is to make a selection of the entire solid, which is not the case because I have a part and I cannot. I don't want to change the complete part. This was something that it could be used. It could be used if I had an assembly, which is not the case. So I have these other two options to choose only a part of the solid. In this particular case, as is said here, single elements. So this one. And now, when I go into the solid, I can choose, for example, only the whole. Okay. And I can change the place where the whole is placed. Okay. I can transform it. Or, for example, okay, let us try. I'm fighting with the graphical stuff again, and I don't want to make this. So I could change let me try to see. Okay, you see that I've tilted the whole. Okay, so I can edit my part in terms of transformation, but I can also edit my part in terms of the shape. And this is interesting because the program identifies the different things I have in my drawing. So this solid here was created coming from the 2D, so you can see that it turns the profile again so that I can change the profile. For example, if I create a fillet, for example, something like this, and say, okay, finish profile edition, I will maintain all the parameters. Oh, sorry. I did not choose my okay, now I think it is that. Okay, and it changed my profile, redefining again the 2D entities. Okay, it recognized this part as born from a 2D profile. If I go into this guy here, it knows that I've created this part from solids, from the 3D side, and okay, I can define new dimensions. This particular case, changing from this arrow, I can choose the arrow. The arrow, it's the side where to change. And it changes also my solid according to the changes I'm doing. Okay. This is also possible, not only for that kind of stuff, but also for this kind of stuff. Okay. So we can do a lot of different things with this edition, and it's interesting because it makes this without that tree that I was mentioning, and it's a little more flexible than what I can call the standard software. Okay, I'm not sure if you have some questions or comments to these things. If it is something difficult or not for you, peaceful? No.
No, everything, you know, you covered a lot. I think I've understood it.
Okay. Please interrupt. Okay.
Okay.
So the idea now was, as I said, I will delete one of the parts, but first, or not, maybe not delete the part and show you another concept that we can work with inside here, which is the concept of blank and blank, or visible, invisible. Blank, okay, and it is not deleted, it's simply hidden or blank, and we can do the opposite anytime. Okay, so it's a way to simplify what we see, and in terms of assemblies it's very useful. Okay, so let us delete the part, assuming that now we had our part done. As I've started, we could do some projections. Okay, there are a couple of different things we could do, okay, in terms of assemblies, interference, and so on. Some calculations regarding important stuff, volume, mass, whatever it is. But this is a very simple part. I don't think it's very important for this example. So to do the drawing, we have mainly two types of options. So let us stay with the three important views. There are a couple of settings that we could have regarding, especially regarding this gap between the views. Not very important. We can create hidden lines, okay, and choose what attributes in terms of type of line. This is also important regarding this round stuff to create a line or not on the tangency, which is important also. But okay, basically create a 2D view, I will put them here, and I will delete this guy on the back. Okay. So we've created a 2D view. I will push them a little up. Being on the 2D side, this is a little different. So the functions are the handling is also a little different. So in terms of translate, rotation, scaling, first translation point, and I can change it dynamically. Okay. Then I can go on the 3D side again and create something like a view of the position of the part at the moment. For example, again, this time I will choose the first option, no views, only this position, and I will leave the others equal. So position, click, and we have a nice view, a perspective view of the part. Now this is standard treatment of the 2D entities. So we have functions for dimensioning. Okay, let's try to create a couple of dimensions. Horizontal, vertical, let us create a diameter. I have some auxiliary functions like axis. Okay, this type also to create this type of axis, because this is the projection of the whole, like in this part here. Okay. I can have radius, whatever. What can I do more in this particular? For example, in this particular case, angle not needed here, but let's show. Okay, this kind of stuff.
Okay.
I can add some text. For example, whatever example part. I have some special characters to as a possibility. Okay, and this text I can basically as I've done to the entities, I can put it whatever I want. Okay, as I want. Then I have other functions like, for example, preparing a title block or a bill of materials. In this particular case, the bill of materials is a little more complex because it needs an assembly part, not only one part, as you may imagine. But for example, the title block, there are some settings that are needed to be done. Okay, we will go a very standard example as it is defined, but it will give you an idea of what is possible. So first, let's create what they call a sheet border. Sheet border is to, in case of if you need to print the sheet, it will create this kind of margins. Okay. We have a definition. I've used the standard definition, but I can use a definition which can define whatever I insert here. So for example, frame, I can draw a frame, I can create center marks, and for each section I can define what I want. Cut marks, a grid, okay, if I want a grid, okay, whatever I want. Okay, and now if I insert the sheet border, okay, I have this kind of stuff. Now title blocks. Title blocks. This is a little more heavy, so I will not go through it. It's interesting. It's, as I said, we need a little work in terms of settings because we need to define what we want. And with the same information, we can export to several places. So to title blocks, to tables, to files, and we can choose what is exported to each place. So you see, in terms of the title blocks, we have this name, standard, drawing number, type, blah, blah, whatever it is. And for each one of them, we can edit and define where it is placed in the title block and so on. So it's the work I've mentioned that we need to make before using it. Sorry, the other one. So title blocks. The other function was the definition. Now it's giving the values to fulfill. So, for example, example part. Okay, doesn't matter.
Right.
Insert it. This one, it is badly positioned, so it's on top of it. But as you see, okay, I've inserted only two fields, example part and cube. If I go through all of them, all of this was automatically fulfilled. Okay, but
Okay.
this is very easy. We can create whatever title block we need with the configuration we need. So these are only two standard options we have already with installation. So it's an example with a logo, which is, I think it's also interesting. And on this side, we also have the complete stuff. So we have the 3D side, we have the 2D side, and when we save, we do the save as, so we save it to some place, doesn't matter. When we save, we have all the information in the same file, okay, which is quite interesting. Also in terms of the file formats, which are interesting. We have some possibilities in terms of what we can read or write. We have the DWG for the compatibility with AutoCAD and the majority of the software that works with 2D. So everybody writes DWG, so it's interesting to be able to read and write that format. DXF, it's a standard also, and many people using it. And the step file in terms of 3D, in terms of solids, currently it is one of the most used formats, and it's very nice. Okay, It passes also a lot of information. So we are compatible with the majority of the software that are around. Okay. Let me see whatever I have more in my list. I think I've covered pretty much whatever I have prepared.
Okay.
In terms of questions, okay, let me know something. What do
Well,
you?
I think you covered